I want you to check your equations. We didn't get to that part yesterday because we spent a lot of time with the phase shifts, so hopefully they made a little bit more sense when you went over them last night. Check your equations. I can put any phase shifts in here, so do it without the phase shifts. You didn't have to do 5. You could do 5 without a phase shift, though. Actually, no, you couldn't. You didn't have to do 5. Because I can't understand why they would give you a phase shift. How do you know if it was a cosine curve or a sine curve? Okay, so just check your answers and see which ones you have a question with. God bless you. You're looking for amplitude. You're looking for period. Because you figure out where 2 pi is, how many complete curves, that's your B. So make sure you find the A, make sure you find the B. And if there's a vertical shift, up or down, look at your resting line or your midline to see where it's going. I took out 5 because they had a phase shift in there. A reflection, number 4 has a reflection. This tells me my cosine normally starts like this. If I flipped it down instead of going up here, going like this, here's the reflection in my curve. Multiply everybody by a -1. And it forces it to go down. God bless you.
Thank you.
Were there any questions on these? No? Okay. These are usually fun to do. Fun in a sense that something is a little fun, right? Where is it supposed to be? I can't get this to come down. Was this the only one on the screen? Oh, okay. So any questions? Okay. So today we're going to do your tangent. So if you can, only because they're not continuous. So we spend a lot with the curves because those are the ones you can manipulate a little bit better. Tangents, remember, we're still going around your unit circle. We're still taking your high and your low points, but tangents work a little bit differently. Tangents are y over x. So sometimes your tangent is obviously greater than 1 or less than -1. So tangents work slightly different. So at my zero, if I take my y over x, I get a 0. Agree? At my 90, if I take my y over x, I get an undefined. Can't do it. It gives me an asymptote here. At my 180, at pi, y over 0, I get 0 over -1. I get a 0. And at 3 pi over 2 or 270, I get an undefined. So the same thing happens going the opposite way. These are your asymptotes. God bless you. So your domain is kind of chopped up. It can't divide by 0. If I took a 45, God bless you, if I took a 45-degree angle right in here, and here's my 45-degree angle. My tangent is y over x. It's going to be a 1. Okay. Remember, the quadrants are not where your highs and your lows come from on the tangent. If I took a 30-60, for instance, let's take a 60. Radical, my tangent says y, or opposite, over adjacent. Opposite over adjacent, I get radical 3. That's about 1.732. So it's close to 2, right? So my 60 is going up here. My 30 would be down in here. So my tangent curve actually goes like this. And kind of repeats itself every pi. Okay, so tangent is y over x, opposite over adjacent. So I draw my 45-degree thing and I say opposite over adjacent. I could put it here as well. So I'm going to put one, then I have, because this is a unit circle, I have to do this. So 1 over radical 2 over 1 over radical 2 is 1, right? On a 60 degree, it'll still come out to be radical 3 over 1 when I reduce it. So it's going to look like this. It's going to go like this. It just follows this little pattern. And what it does is, it keeps doing this, repeats this, every little bracket. The asymptotes represent just like a roadway almost. And you're going like this each time. So you're coming through going like this. So tangent repeats itself. And if I go from negative 90 to positive 90, negative 90 to positive 90, negative 90 to positive gives me 180 degrees. So my cycle is not 2 pi. My cycle is pi. Normally your cycles, these work very different than your other curves. So kind of like put the other curves to the side for a minute.
I get how you got like the point at 1 and then the one like from radical 3. But how'd you get the one below? Like that little point? No, like up a little. Yeah, that.
Oh, 30. So 30 would say opposite over adjacent. And so this comes somewhere less than 1, right? Somewhere less than 1. So it's just a pattern. You can just keep going through these and come the opposite way. Tangent is negative. This is still quadrant 1. Tangent is positive. Quadrant 2. Quadrant 3. Quadrant 4. So it still tells you where your positives and negatives are for tangent. Now the domain is something we have to work on. The range says, well, you're going to get any number in this range. This is going to go on and on and on. If I put in my calculator, put in a tangent in your calculator of 89. So I'll do it up here so you don't have to take out your calculators. Let me just put myself in degrees. So I'm going to take the tangent of 89. The tangent of 89 is 57 point something. So do you see me keep going all the way up like this? It'll keep going on, and the asymptote acts like a barrier. I can't cross over that barrier. Okay. This will repeat itself every pi. See pi in here? Every pi. So our cycle is pi. Different than your regular curves. Yes. Because when we did our curves like this, we had to go through 4 quadrants to make a complete cycle, right? Before we could start again, right? Well, this one, we go here, and it spans from negative 90, which is 90 degrees here, to positive 90, which is 90 degrees here. So it takes 180 to complete that little thing like this. So we skip over the asymptote, and we do that again. It's the same exact motion. It's not a curve, but it just skips over that asymptote and goes the same thing. So it's taking it 180 degrees instead of 2 pi. Granted, it's going across the 0, but still, aren't I still taking 180 degrees every time I go like this, right? Now, your domain is a little bit different. So we're going to start like this. My domain says you can use all real numbers except what? Except, give me some numbers here. Except what numbers can I not use? Give it to me in radians. Pi over 2. 3 pi over 2. Negative pi over 2. Okay, now let's look for a pattern. I got 1 pi over 2, 3 pi over 2. What else do you think I can't use? Well, no, if this kept on going, if I kept on going out. 1 pi over 2, 3 pi over 2, 5 pi over 2. Then what? 7 pi over 2. Because aren't I going every pi to do this? I have to go 180 and I can't do it again. 180 and I got to stop again. So I noticed that if I do pi over 2's, it's not every pi over 2 because 2 pi over 2 is pi. And I can do this one, right? God bless you. 4 pi over 2 is 2 pi, and I can do this one. So somewhere I have to find a way to say this. So we do this for domain. The domain is real, except for when x is n pi over 2, where n is any odd integer. But it makes total sense to us, right? Because aren't we taking the odd ones? If I say n pi over 2, you can put any odd integer in here, positive or negative, and I can't use that spot. Because at the 90 and at the 270, opposite polar things, if you will, opposite poles, I can't use those guys. So every 180 degrees in here, I get stuck. So this is how we write the domain. I can use real numbers except x is equal to n pi over 2, where n is any odd integer. Yes?
I guess that, like, the asymptotes are every pi, but is it always going to be the same like this? Pi over 2 always going to be an asymptote?
Well, they're not like every pi. It is at the odd 90s. The cycle itself is pi, or 180 degrees. It takes me 180 degrees in between these little asymptotes. In between these asymptotes is 180 degrees. So inside, wherever those land, if I squish these down, if I did a frequency on this, and I'll do a frequency so that you can see if I squish this down, then my period is going to change a little bit. But right now, it's your cycle, instead of being 2 pi, just takes you pi. If you think of this, we can't use this one. We can't use this one. So here's 180 degrees. Here's 180 degrees. So every 180 degrees, I pass through a full cycle of tangent. Lane?
Wait, it says where n is any odd number?
Yes, odd integer.
Okay.
It has to say integer because you can't use like 1.7, 2, 6, 9. You can't use any of those. It has to be an integer. Okay? Tangent, we really don't spend too much time with this because we like to use the curves. We spend a lot of time with the curves, and those make sense to us. So tangent works a little differently, and as a result, cotangent works a little differently. But we're going to look at your reciprocals. Yeah. So that's about all we really spend on. We're going to take the reciprocals. I'm going to move this up just a little tiny bit. Cosecant is the reciprocal of which function? Sine. So the first thing we're going to do is plot the sine curve here. No transformations, just the basic sine curve. So we're 0, 1, 0, -1, 0. And we're going to go the opposite way. 1, 0, 1, 0. So it's going to look like this. Okay. For the domain for sine, what is the domain for my sine curve? Negative infinity to infinity. What is my range? -1 to where? 1. Okay. Now, reciprocals say take that sine and flip it over. So here's my, we're going to start up at the top here. Here's my 90. When I go to my curve over here, I always draw this because it's kind of helpful to visualize this. When I'm at my 90, my sine was 1 over 1, right? It's my y value. Agree? My sine is my y, so I'm just going to say 1 over 1. When I take the reciprocal of 1 over 1, what do I get? 1. So anything that's up here is going to stay there, right? The reciprocal of 1 is 1. So at my 30, my sine of 30 was 1/2. So my cosecant of 30 should be what? 2 over 1 should be 2. Agree? So 30, here's my 30. is going to be up here by the 2. Agree? That's the sine curve. That was your sine curve. This is how I do reciprocals. I do my regular curve. You're going to see the pattern in 1 minute. If I'm a 30 over here, and my sine is 1/2, and I come over here, and I'm a 30 over here, my sine is going to still stay 1/2, right? When I'm over here. So now, when I flip this over, I'm going to get a 2 over here. I'm in quadrant 2. I'm angle 150.
I don't get what you did with 1 over 1.
Well, because I got to take, the sine of 90 is 1. So the reciprocal says flip it over. So 1 over 1 is still 1. So any of my 1s are going to flip over to 1s. So look what this makes. It makes a little u. It makes a u. This makes a u. The second point was like at 150 somewhere over here. The opposite 30 over here. Just to show you that I'm in quadrant 2. Now, let's take a look at these bottom guys. And negative 1 over 1. When I take negative 1 over 1, doesn't that become negative 1? The reciprocal. Okay? So let's go over here. I'm going to take negative 30. Negative 30 puts me here. What's the sign of negative 30? What's the sign of negative 30? Just follow me. 1 over 2, but is it positive or negative? Negative. Negative 30. I'm in what quadrant? 4. So what's the reciprocal of negative 1/2? Negative 2. Oh, so again, I'm coming like this. Then this guy, I'm coming like this. So I make a little u down here.
Wait, why do you have it on the, I just know to put it on the other side.
Because I went to the negative side. So here's negative 90. Negative 90 puts me down here. I came the opposite way. So the reciprocal of negative 1 was negative 1. Here's my 30-degree reference angle. This is sine is negative 1/2 in this quadrant, right? And in this quadrant, isn't my sine also negative 1/2 in quadrant 3? If I come backwards, I'm actually in quadrant 2 going backwards. Okay, so I kind of see a pattern here. I see this is going to do the same.
How did you know it's good sign of 30?
I just picked a number. I could have used 60, 45. I could have used any of them. Sine of 30 is easy because it's 1 over 2. If I use a radical, then we have radicals, and I just picked that one. Okay, so now, I don't know what's happening here. Like, what made this look so strange? So let me come to my 0. So I'm at the 0. Sine of 0 is what? What's my y value at 0? 0. So let me take the inverse, the reciprocal of this. What's the reciprocal of 0 over 1? 1 over 0. Whoops. I can't do that, right? Asymptote. Good. So this makes an asymptote. I could see something broke my graph up, right? So where else do I have a 0? Right here. If I flip over 0 over 1, I get 1 over 0. Oh, asymptote. And everywhere I have a 0, I cannot take its reciprocal. There's your cosecant. So we walked through this step by step, but now when you go to do this, this is how easy it is. Here's my sine curve. So at the zeros, I make asymptotes, and I just go like this.
So you just,
That's my cosecant.
you just draw curves.
You start with your sine curve. Whatever your reciprocal function is, do the reciprocal function first. Do the regular function. And then at the zeros goes your asymptotes, because you can't flip over 0 over 1. At the 1s, they flip to 1s. So your curve goes up or down. And these little points in here, they're fine. I'm just sketching.
How do you know that negative
because I went to this quadrant. I went to quadrant 3 and 4. I went down here. So my sign was negative down here. It was negative 1/2. I flipped it over to get negative 2/1. Is it my sign? My sign of 30. I picked 30 because it's easy. So the sign down here of this is 1/8, this is 2/10, is negative 1/2. So somewhere over here is my negative 1/2. I flip it over to negative 2/1. I'm just making a sketch. I don't want those points there. But I wanted you to see where your reciprocal forces it to go. Okay, so the ones in blue is your cosecant curve. All right, that's the cosecant part.
So like when it asks you to do that, like you don't even have to do like.
No, you're gonna do this. You're just gonna go like this. You're gonna make your sine curve. This is the easiest way to do it. Make your sine curve, right?
And just draw parabolas on top of it.
Yeah, just make asymptotes at the zeros and go like this.
So we don't actually have to like,
You don't have to find the points, no. But I just wanted to show you, if I just drew that, how many of you would say, where'd you get that U from? Where'd you get that from? How did you know it went up there? So the best way to do it is to show you where it comes from. And then just explain to you how you're going to draw it.
so on the test,
You're just going to do that. Yeah, you're only sketching. So all you care about is the test? I see. So let's work on the domain here. The domain for this guy is a little strange. It looks like I can use most things, except, now give me some values of x that I can't use. Which ones am I looking for? Where my asymptotes go. Can I use 0? Then where else? 2 pi. What do you think comes next? 3 pi. Every 1 pi, 2 pi, 3 pi, 4 pi, negative 1 pi, negative 2 pi. So we have to find a way to say this. So my domain says this, real, except when x is equal to n pi, where n is any integer. Isn't 0 an integer? 0 is an integer, right? It's neither negative or positive, but it is an integer. So if I put 0 pi, don't I get 0? If I put 1 pi, I got an asymptote. 2 pi, an asymptote. Negative 18 pi, I got an asymptote. Okay, this is important. This is what we had to get to today. My range is also a little different too. What's my range? My range are all my y values. Negative 1 to positive infinity. Is that where you want to go? Negative 1 to positive infinity? Okay, so where else? Okay, so negative infinity to negative 1. Soft or hard? My range is my y's, guys. I want to go from negative infinity, stop at here, right? Then I want to jump over, and where do I restart? Or, and from 1 to infinity. It is the complete opposite of sine. Sine does 1 to negative 1. Its reciprocal does everything but that, right? Good? I know you probably did not see this last year, right? Honors kids were supposed to graph this, but because you guys were squished at the very end and really didn't have the time for this, I get this. I get why they didn't. And we didn't expect you guys to get this far. Okay, let's try secant. Secant should work a little easier. Secant is the reciprocal of which function? Cosine. So the first thing we're going to do is put our cosine curve here. I'm sorry when my marks are off, but I can't stand on top of it and draw it. And from the side it's hard, but you can see where it goes, right? It's very hard to make these curves on this board. Okay. They look good? Thanks. All right, so what's my domain for cosine? Uh-huh. Yeah, all real numbers. Negative infinity to infinity. What's my range? Good. And these get hard brackets because I can use the ones. Now, we know what we did the first time for secant. We're going to apply that same process here. Where are my asymptotes going to go? At the zeros. Because I can't flip 0 over 1 over, right? To 1 over 0. So at the zeros, make your asymptotes. Watch how nice this works. Because we know why we did this. We're going to apply the same thought here. And the ones and the negative ones stay the same, right? So here's my negative one flipped over. Here's my graph. Here's my positive one flipped over. Here's my graph. It is the exact same thing. Right? Ah. Very good. So let's think about that for a second. Gabby has a good thought here. The other one was at pi, not at pi over 2. So what's the shift here? 90 degrees. Isn't the cosine and the sine co-functions within that 90 degrees? Aren't they co-functions because they're complementary angles? They're 90 degrees. Don't I shift from 10 to 0, 1 every 90 degrees? Doesn't that make sense? Yeah. So now, look how easy this is. Let's see if we can get the domain without spelling it all out. X is equal to
n pi over 2, where n is any odd.
Oh, you go, Chris. Very nice. Very nice. Which one is this just like? This one is just like the tangent. Good. And so there's your reciprocal function. And the range, yes, I'm sorry. And the range from negative infinity to negative 1 and 1 to infinity. It's the same exact as the cosecant range. It's using everything but from negative 1 to positive 1. Basic curves. Okay? Now the cotangent, let's work on the cotangent and finish that up. Okay? The cotangent, I'm not going to put the tangent curve out here, because then there's just too many curves for the cotangent. I'm going to go around here again. Hang in there. It's the same pattern, but we just got to figure out where it goes. So if tangent was y over x, what is cotangent? X over y. So at the 0, if I take my x and I put it over y, ooh, can I do that? No. Asymptote. Where else do you think I would have an asymptote? Pi. Because isn't that where my y is also a 0? Oh, we see something happening. Oh, sorry, that's really way off. Sorry. It looks like the tangent, but it's a little bit different. Okay, so let's look at the 90. At the 90, it says x over y. Whoa. Now that, I have no idea where that happened. I wasn't even close to leaning on the board. Okay. Okay, at the 90, x over y, 0 over 1. What do I get? 0. So where else do you think I have zeros? Negative. So here's an asymptote. So here's an asymptote. So here's a 0. Here's a 0. Here's an asymptote. Now again, I'm going to my 30 because the 30 is a nice one. Or we'll go to 30. So I label this a 30. So this is my, this is my unit circle. So this is 1/2. This is radical 3 over 2. This is 1. So tangent is x over y. So keep change flips, knocks this out. So the tangent of 30, the cotangent of 30 is radical 3, which is the opposite of my 1 over radical 3, right? The reciprocal. Radical 3 is like 1.7. So where 30 I was before here, I'm now over here. 45, the tangent is 1. What's the cotangent of 45? 1. So here's my 45. I came down to 1. So watch what my cotangent's doing. It's going this way. Your tangent went from left to right up. Your cotangent goes from left to right down. So the same pattern all the way through. Same pattern. What's the cycle of cotangent? How long does it take to complete one of those little 180 in pi? The cycle again is pi. Let's see if we can get the domain. The domain is real except what? Except, so how do I say that? So pi's, how do I put this with the n thing in it, in there?
When n is any integer.
And so I say n pi, where n is any integer. Which one was this just like? What else has a c? The cosecant. The cosecant has a c, the cotangent has a c. The secant has an s, the tangent has a t. So they're close together, kind of. Those domains are the same, these domains are the same. What is the range for this guy? All real numbers. Okay? Again, we don't spend a lot of time with the cotangent as well because they're really not our curves, so we don't like them as much. Let me just go over this next one, how you're going to have to start this one before you all panic. So, first thing I want you to do is make this into its reciprocal. So we can all do that. We can say I need 2 curves in 2 pi. So here's my 2 curves. I'm going here. So I'm 1. I got to split these up, agree? I'm just making my cosine curve. Here, 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 here. You don't have this? Because isn't it reciprocal? You're going to do these off your reciprocals. So make your cosine. Didn't we do that? Isn't that how we found ours?
Wait, what number are you starting? What's that? Like not one?
Because I did cosine. I went to a half. Is my amplitude half?
Oh, yeah.
I'm saying do this graph like you would normally do your cosine curve, right? Wouldn't you? Yes. The amplitude is going to be the same. The amplitude doesn't change. The frequency doesn't change either. God bless you. Okay, give me 1 second, guys. Plot this, and then from there, guys, this is what you're doing. Look, there's where your asymptotes are. This is your graph. Go back to your regular graph and do those functions. We'll work on the domain parts when you come back. Enjoy your long weekend. Thank you.